In this lecture, let us talk about encoders. The outline of this lecture as follow. First, we will try to understand the encoders. Then we will talk about 4 to 2-bit binary encoder, and finally, we'll talk about 8 to 3-bit binary encoder. Now, first let us talk about encoders. Encoders are digital devices that are used to convert a signal or certain data into binary codes. As you guys are already familiar, the digital system only understand the binary code. Therefore, it is necessary to convert the discrete data into into binary codes. So further, encoders are the combinational circuits that perform exactly reverse operation of decoders. In the last lecture, we have talked about decoders. In decoders, we assign binary codes and at input. So input is the binary codes are the binary data, and we get the corresponding data at output. So in the previous lecture, we have talked about if we have n bits or n inputs, those are the binary codes. Then the corresponding outputs data lines are 2 raised to power n. And in this case, in case of encoder, it is the reverse of it perform the reverse operation of the decoders. So in case of encoder, if we have 2 raised to power n inputs, so these are the 2 raised to power n data lines. So here this is the simplest form or the simplest circuit of the encoder. Here 2 raised to power n are the inputs, then the corresponding outputs are n. So these data lines can be described with exactly n binary bits. So let us talk about some example. First, we'll talk about 4 to 2-bit binary encoder. So in 4 to 2-bit binary encoder, we have 4 data inputs like here, and those we will describe with the 2 binary inputs or the 2 outputs. So as you know, if we have 4 data lines, so with the help of 2 binary numbers, we have 2 raised to power 2, which is equal to 4. So 2 bits can be described in 4 different ways. So here we have, in this example, we have 4 data inputs. So those are starting from D0 to D3. So first input is D0, the other is D1, then we have input D2, and D3. These can be described by 2 binary bits. So here the block diagram is like this. It is 4 cross 2 binary encoder. So we have 1 2 3 4 inputs data line. Those are D0, D1, D2, and D3. These are the inputs. So the corresponding output which convert these inputs to the binary codes, those can be described X and Y. Okay, these are the inputs. So this, let me draw the truth table. Truth table is as follow. This is the truth table. So these are the inputs and x and y are output. So when d is equal to 0, all the inputs are active low. In that case, x should be equal to 0 and y should be equal to 0. Sorry, no, I am sorry, only one input should be active high at a time. So in the first case, when d naught is active high, the remaining inputs are active low. In this case, I will assign a combination x is equal to 0 and y is equal to 0. Suppose d naught is equal to 1, d1 is equal to 0, d2 is equal to 0 and d3 is equal to 0. All the inputs are active low except one. So it will work like this way, only one input at a time should be active high, the other should be active low. So in first case, d1 is active high, d naught is active high, d1, d2 and d3 are active low. So I will assign this binary code, x is equal to 0 and y is equal to 0. Next, d naught is active low, d1 is active high, d2 is active high, active low, d3 is active low. Only one input is active high and the remaining are active low. So in this case, I will assign x is equal to 0 and y is equal to 1. So this binary combination are the binary code. Next, d naught is equal to 0, d1 is equal to 0 and d2 is equal to 1, d3 is equal to 0. In this case, the output would be 1 0. And finally, when all the inputs are active low except d3, in this case I will assign x is equal to 1 and y is equal to 1. So by two binary bits, so I can assign, I can describe this, I can assign the binary code to these data lines. So its circuit would be, I can construct a circuit, digital circuit, by using OR gates. So the inputs are d0, then d1, d2, and d3. So we have two outputs which are x and y. So this is the OR gate, and its output is x. This is the OR gate and its output is y. So I know that x is equal to 1 when d2 is active high or d3 is active high. So I will connect d2 and d3 with this OR gate. So from here it is obvious that when d2 is active high or d3 is active high or both are active high, in that case x is equal to 1. Next, y is active high when d1 is equal to 1. So I will, let me use different wiring. So let me use the red color. So I will use input d1, I will connect with this OR gate, and y is active high when d3 is active high. And this input is useless and we will not use this input. So from here, when d is active high, d naught is active high and the remaining inputs are active low, in that case we will get x is equal to 0 and y is equal to 0. So when D1 is active high, in this case, D1 is active high, in this case y should be equal to 1 and x should be equal to 0. So remaining inputs are active low, so x is equal to 0. In this case D1 is equal to 1, so I will get 1, y is equal to 1. And when D2 is active high and the remaining inputs are active low, in this case I will get this output, D2 is equal to 1, so x is equal to 1 here, and y is equal to 0 when D1 is equal to 0 and D3 is equal to 0. So finally when D3 is active high, in that case this is the input of x and input of y, so I will get x is equal to 1 and y is equal to 1. Similarly, we can construct 8 to 3 bit binary decoder. Okay, now let us talk about 8 to 3 bits in binary encoder. So 8 to 3 bit binary encoder, let us talk about its block diagram. This is 8 to 3 binary encoder. It must have 8 inputs, 1 2 3 4 5 6 7 and this is 8. So these are D0, D1, D2, D3, D4, D5, D6 and D7. So the corresponding outputs are x, y and z. X, y and z. Now let me draw the truth table for 8 to 3 bit binary decoder. So we have 8 inputs, those are D0, D1, D2, D3, D4, D5, D6 and D7. These are the data lines, these are the inputs. So corresponding output can be written as x, y and z. So in first case, when D1 is D0 is active high and the remaining data lines are active low, so in this case this is 1 0 0 0 0 0 0 and 0. So the corresponding, the binary code would be x would be equal to 0, y is 0 and z is equal to 0. In next case, the input D1 is active high, the remaining inputs are active low. Keep in mind At a time only one input should be active high, the remaining should be active low. So in this case, the output is 0 0 1. Next, D2 is active high, the remaining inputs are active low. This can be written as so the output would be 0 1 0. In next case, D3 is active high, for this the binary code is 0 1 1. So next, D0 is equal to 0, D1 is equal to 0, D2 is equal to 0, D3 is equal to 0, D4 is 1, D5 is 0, D6 is 0, D7 is 0. So the binary code would be equal to 1 0 0. From 3 inputs we have total combination would be equal to 8. So in next case, D5 is active high, the corresponding binary code is 1 0 1. In next case, when D6 is active high, 0 0 0 0 0 0 1 0. So in this case the binary code is 1 1 0. Finally, D7 is active high, the binary code is 1 1 1. So in similar fashion which I did for 4 to 2 bit binary encoder, I can construct a 8 to 3 bit binary decoder by using OR gates. So the inputs are D0, D1, D2, D3, D4, D5, D6 and D7. These are the inputs. So I will use 3 OR gates corresponding to 3 output. This is for output X, this OR gate is for output Y, this OR gate is for output Z. So I know X is active high when D4 is active high, D5 is active high, D6 is active high and D7 is active. So I will use these inputs with OR gate X. So this input, this input, this input, this input. So D6 and D7. So when any of input either D4 or D5 or D6 or D7 is active high, the output X is equal to 1. Next, here you can see that output Y, which is active high when D2 is active high. So let me use different color wiring, red color. So D2 and Y is active high when D3 is active high. So I will use this input, and Y is active high when D6 is active high. So I will connect this input with this OR gate, and when D7 is active high, Y is active high. So from here, if any of input D2, D3, D6 or D7 is active high, the Y would be equal to 1. It would be active high. For Z, when D1 is active high, Z is active high. So let me use some different color, this blue. So I will use this input D1 with this OR gate, and Z is active high when D3 is active high. So again I will connect this input with this OR gate, and Z is active high when D5 is active high. Again this would be the input of this OR gate, and Z is active high when D7 is active high, and this input no need to use. So this is the encoder that assign the binary code to 8 data line. This is 8 to 3-bit binary encoder. In similar fashion, we can construct 16 to 4-bit binary decoder. So for that case, 2 raised to power 4 is 16. We need 4 output, and if we have 128 data lines, so 2 raised to power 8 is equal to 128. So in this case we need 8 output. So if we have 128 inputs, then those can be described with 8 outputs. That's it. I hope you have understand the concept of encoder. It is the exactly reverse of the decoder. Its function is exactly reverse the function of the decoder. So next we will talk about multiplexer. After that we will discuss 8 BCD to 7 segment decoder. Thank you. That's it.